Hi everyone! In this tutorial we are going to learn how to make a morph animation with the most simple and fast way possible using only a single line of VEX code. Hope you enjoy this one. Okay, let's start. Let's place a geo node and let's call it morph. So let's place our base geometry. So let's start with a sphere. Let's convert this to polygon and 10. Let's place a box. Okay. Sphere, box. And let's use a more complex geometry. In our case, a human figure, a male. So I'm using agent node. FBX, and I'm going to pick up a model from that studio. Here we go. Okay, so we have everything here. So as you can see, our agent, our man is on the floor. So let's put everything on the floor. Let's place a transform here. Let's use copy parameter and translate here. So our sphere is on the floor and our box copy parameter. Here we need to divide by 2. Okay. So now let's put everything. You don't need to do this, but I want to have everything on the same size. So the box is alright, but the sphere is way too big. So let's decrease this to half the size, something like that. Cool. I think, yeah, the agent is a little bit to the front. You don't need to do this, but I just like to have everything in place. Oops. Sorry, let's try again. Okay. So everything is on the same place. Again, you don't need to do this because we are going to use particles and they move around as we want. And you can try that in a bit after we do the system. So we are going to use scatter points, okay, then a single line of VEX code, and then convert those particles to VDB and polygons. So first let me use a convert node to polygons here, okay, because this agent is not made of polygons. Okay, now everything is all right. So let's place a VDB from polygons. Okay, I'm going to use really small. Let me start making this for the human, the male FBX, because it's the more complex geometry, and we are going to use a really small voxel size. Let's change this to a small 1 to small value. We need to make this even smaller, and this small. Okay, that's cool. Let's subdivide this just a little bit. So we lose a little bit those polygons. Okay. So right now we need the same VDB for each one. Okay. So instead of creating one and creating one again from polygons and put the same values, we can just right click, actions, and create reference copy. It will create a node that we need, a VDB from polygons, the same node, exact node, but as you can see, all the values are linked. If I press here, are linked to this first one. So if we change here, for example 0.005, you'll see that here it will change it too. Okay, pretty cool. Let's go back to 0.001 and let's do it again. Actions, create reference, and link this to the sphere. Okay, everything is all right. So now we need to create a scatter. Let's increase this. So I'm going to use 1,600,000. Okay, let me free. Okay. So we have a lot of points. Maybe this will work. Let's wait a bit. Oh, I forgot to turn on off the relax iterations, so it will be faster. Okay, so right now, let me decrease this just to show you one thing. Right now, even if we are using volumes, we are only creating points on the surface. Okay, so we need to change this to surface to density. Okay, so we have fill interior, we have a volume. Okay, so now we can scatter points inside that volume. That is what we want. Okay, so now we have points inside that volume and we can increase this. Let's go with 1, 2, 3. Okay, so we have 1 million points. Let's increase this 1 million and a half. Okay, cool. And we will do the same as we did before, because we want to scatter points here on these other volumes with same parameters. So actions, create reference, so we have the sphere, it's creating here the VDB. Okay, so we have the sphere. Now we need to make the same for the box. Okay. I don't know if we need a fill interior, because we have the interior band really small. So yeah, we get more points here on the foot. I was not liking that part, so when we get back to polygons VDB from particles, that would mess up. So we have the points, okay, the scatter points, and we will use a simple vex function called lerp. Let me show you. So we are going to use this simple function with vectors and the amount float. Okay, so this function, we have a starting point, starting in our case vector, starting position. The value 2 is our goal position, and then the amount. This amount, as it says here on below, it goes from 0 to 1. If it is 0, it has the value of value 1, okay, our starting position. If it is 1, it will have the value 2, okay, our destination position. So let's use this simple function with a point triangle in our project. So let's put point triangle. Okay, so we have our first scatter on the first input, our scatter box, let's call it scatter sphere, scatter box, and we have here our scatter man. Okay, so let's wire the box to the second input and the scatter man to the third input. And let's use that lerp function. Okay, we want to lerp the position of each point, right? So the parameter we want to change is the position, and we want to use a lerp. Let's call it starting position, destination position, and amount. Right, so let's change these parameters, okay, these names with the values we want. So the starting position will be the current position of our point, right? The destination position is the position of a particle on the other scatter, so that's why we are wiring these to the different inputs of point triangle. So here it's more complex, but we want to get the point from the input 1, because now we are going to get the box. Okay, so the input 1, 0, so this is 0, 1, 2, 3. So we want the input with ID 1. We want to get the position and use the point number to compare. Okay, so for example, this point triangle will run for each point. So imagine we are on the point with the point number 300, for example. It will get the same point on the scatter box with the same position, with the same point number, and we'll get the position of that point. Okay, so we have the starting point, the starting position, or current position. The destination will be the position of the same point on the other scatter. Okay, and then we are missing the amount, and for that we are going to create a channel float. Let's call lerp to cube. Oops, to cube. Lerp to cube. Okay, and I'm missing the parentheses. So right now, if I press this little icon here, you can see now we have a slider here, lerp to cube, and if you can see that if I go to 1, we have the goal position is the points from this, the position from this scatter box, and if we have 0, we are on the sphere. Pretty cool. Now you ask me how we can do the same for the scatter man. As you may know, I think I explained this on the second tutorial I made. The coding in every single platform, in every single language, you read from the top to bottom. So first read this, and then you can just copy paste this line, oops, and do the same, lerp the position, but in this case we want the third input, or the input with ID 2, and lerp to man. Let's call it man here. Lerp to man. And because the coding reads from top to bottom, this second slider will overwrite this one. Okay, so if you want, you can lerp to the cube and then lerp to the man. If you want to go back to the sphere, you just need to turn everyone to 0. Okay, so this goes to cube, or the second one, and this goes to the third one. And if you want the fourth one, you just need to copy this and put on the line below, because the code will read first this one and then we'll read the second line, and it will overwrite the first one. Okay, so when we have everything turned on, the points are going to the cube, but right after that it is going to the man. Okay, so the complex part is done. So right now we just need to convert this to a VDB from particles. Okay, we need a really low value here. Let's wait until my computer thinks a little bit, because there are a lot of points. Okay, so let's change this a bit. I'm going to turn this to manual because I've tried this and from particles. So here I know I need something low like this, and here is 004. Okay, and here 1, because I've tried this before. So if I turn this to auto update, let my computer think a little bit, and here we have, maybe that's way too big. Let's try with the man. Okay, pretty cool. Let me try this. Maybe I don't need that lower. Nah, that looks fat. So let's go 006. Okay, cool. Now let's smooth this a little bit. Okay, it's better. Let's try Gaussian. It's way too strong. Back to mean. Maybe 2. Can I use float? Nope. Okay, 2. That looks cool. And let's convert these to polygons so we can render this with normal material. Oops, not that convert. It's convert VDB and turn this back to polygons. Okay, let's try the box. This is the middle. Let's see. And let's try the box. That looks cool. Maybe we have really low points, so let's increase this one. Let's go back to 0.08. Yeah, it looks better. I think it's the middle between the box, the best value for the box and for the man. Because if we increase this value, the box will get good, but the man will get really fatty. And if we lower this, the cube will get some holes. Let's check the spheres. So the sphere looks cool. So we have our morphing. Let's go back to our points because I want to show you one little thing. So as you can see, when we are increasing this value, you can see we get something like a grid here. That is because of our scatter. Okay, even if we have random mass points, it is getting that grid. I turn off the we get that grid, as you can see. So one way to break this grid while we are lerping the points from one position to the other. Okay, One way to break that is to add a simple noise into our particles. So let's put a point up. This is not part of the morphing, it's just a little add-on to break that grid effect. Okay, as you can see, we have a lot of grid effect. So let's put it simple with a point up. Let's place a turbulence. Okay, we want a parameter. Let's call it noise force. Okay, and it will be a float that goes from 0 to 1. So let's wire the position. Let's multiply our noise with our noise force, and let's add that noise that will displace our current position. Okay, something simple as that. I want to turn this to 3D noise, something simple as Perley noise. Let's promote this parameter, and that's okay for now. Yeah, if you want, you can change these values. So right now, you will, let's promote to offset to, sorry, because this will give us the animation that we need. So right now we don't have any noise on our particles, and if I increase this, you can see that we are adding some noise to our particles. So right now we are breaking that grid effect. You can even increase this, something with more strength. Okay, I'm going to increase the frequency. Okay, so we have more with a little bit more noise. Okay, and on the offset, let's animate the Y position, so every single frame the noise will be different. It will go up, kind of a flame animation. Okay, and we are not using any keyframes so far. So the key thing here to do, I'm going to do for the box, so in case you want. The trick here is when we are increasing this slider, we are adding the noise. Okay, because if we keep the noise force always on 1, even when we have the 0 or 1 on lerp, you can see a box here and you can see a sphere. So let me show you with the keyframes what I'm saying. So I want to transform from the sphere. Let's turn off the noise. I want to transform the sphere on frame 60, and in frame 90 I want to go to the box. Okay, right now if we check, we get that grid effect. So during this transformation, I want to add our noise. Okay, so let's go frame 55. Let's increase this. Let's add a keyframe, sorry, on 0. On 60, let's add the full noise. On frame 90, let's add a keyframe with 1. And after 1 second, let's turn off our noise. And because our lerp to cube is already in 1, we will have a smooth transition from the sphere to the box. And if we convert everything, see that we have a box. Let's go to the middle here, that we have the lerp going from the sphere to the cube, and we have the full noise. See, pretty cool. I'm going to do a flip book so you can see all the transformation. Let's check the settings. Okay, let's start. And And it's done. As you see, Vex can be really helpful and easy to use. The animation could be really complex to do, and using only a single line of Vex we are able to morph objects. Hope you enjoyed this one. Don't forget to share your results with us. Have a nice day and see you on the next tutorial.